We're going to learn some trig identities today. So let's watch and see how easy these trig identities can be. First off, we have in front of us here a picture, a lovely little right triangle. And you used to love right triangles because basically in the 6th grade you knew that every time you saw a right triangle, you knew it was a squared plus b squared equals c squared. And they gave you nice numbers to work out and everything was fun. Then along came big old trig. And we learned that the Greeks learned a lot about these right triangles, and for some reason they started putting them on unit circles and graphs. So now here comes the unit circle, and then we put your triangle in a quadrant. And we're going to put this triangle here in the first quadrant. Well, guess what? Pythagorean's theorem is still going on, except we know now we don't use A, B, and C. We learned that this x side here was the cosine of the angle, and we learned that this was the sine of the angle, and then this was a unit circle, so this hypotenuse always had a unit of 1. So now, can we take Pythagorean's theorem and turn it into cosine and sine? Absolutely. There's your first identity. Cosine squared plus sine squared will get you 1 because it makes sense. Side squared plus side squared gets you the hypotenuse squared. So then, of course, we're going to take and we're going to make other formulas off of this formula. So for example, if we applied our algebra to this, we could take this cosine squared, move it to the other side, and get sine squared is found by taking 1 minus cosine squared. And you're right, we don't have to do that just with cosine. We could take the sine and move it to the other side. And that would get us cosine squared, cosine squared equals 1 minus sine squared. And then those silly Greeks, they even applied more algebra to this. So let's take these two and move them down here. And then the Greeks did this. Let's take everybody and divide them by cosine squared. And you're thinking, okay, why would we divide by cosine squared? Well, watch what happens. Cosine squared divided by cosine squared is 1. Sine over cosine is, tangent, and it's still going to be squared. And 1 divided by cosine is secant, so it's going to be secant squared. So I've got yet another identity. And you're right, just like the other one where we moved cosine over, we can do the same thing now and divide by sine. So what happens if I divided everybody by sine squared? Well, cosine divided by sine is cotangent. Sine squared divided by sine squared is 1, that's easy. And 1 divided by sine squared is cosecant squared. So these are called your trig identities because now you have another way of obtaining all your trigonometric functions. See? You have a sine, you have a cosine, you have a tangent, you have a cosecant, you have a secant, and a cotangent. So you've got all your trig identities yet again, but a different way. So how is this going to play out? What I have written up here is, this is Mama. And then we can manipulate Mama to get all of our other identities that we just did on the other page. And I never remember these. I manipulate to get them by knowing I can subtract and knowing I can divide. You'll see more and more of that, and really it's not going to be as foreign as you think. So, how are they used out? If there's a triangle in quadrant 3 and the cosine is -3/7, find the other 5 trig functions. You may say to yourself, wait a second, I just took a test on this, and the vast majority of you did awesome on that test. Can I use the same thing I just did on the test? Absolutely. Or you could use your identities. Okay, sine. I know what cosine is. And up here, I have this formula right here. Okay, so I'm going to do that formula. Sine squared is 1 minus cosine squared, but I know cosine is -3/7, so I'm going to take -3/7 and I'm going to square it. 1 minus 9 over 49, which gets me 40 over 49. But remember, that's what sine squared is. Sine squared is 40 over 49. So how do I get squared out of there? I square root it, because I don't want to know what sine squared is. I want to know just what sine is. And I figured out that sine is plus or minus, because when I take the square root off of a squared, I have to do plus or minus, radical 40 over 7, because the square root of 40 can't do, the square root of 49 is 7. But I can break down 40 into 2 radical 10 over 7. Now my question is it plus or minus? That's why they told us quadrant 3. If I come back and I remember, all students take calculus. So in this third quadrant, only tangent is allowed to be positive. Anything else is negative. So there is my final answer. For sine, it's going to be negative 2 radical 10 over 7. Boy, that doesn't look like a negative. There we go. All right, tangent. We've got a couple of ways we can find tangent, but I like my good old-fashioned way. Tangent is take your sine and put it over your cosine. Negative divided by negative means my answer is going to be positive, which makes sense because I'm in the third quadrant here. And then we know our shortcut is the denominators will cancel out, so it's 2 radical 10 over 3. And then my cosecant, secant, and cotangent, well, I can get those by just flipping, or if I wanted to, I could use these formulas up here. I could use either, let's see, I don't want to use that one. Don't want to use that one. Oh, cotangent, tangent, secant, cosecant, but yet again, I'm still just going to do my good old flipping because that's the easiest way to do it. All right, so secant matches up with cosine. That's an easy flip right there. So that answer is 7 over negative 3. Cosecant is the flip of sine. So that's 7 over 2 radical 10. And I'll rationalize the denominators to get 7 radical 10 over 20. Don't forget the negative sign. And then cotangent is the flip of tangent. So that's 3, 2 radical 10. Rationalize up those denominators, so I get 3 radical 10 over 20, and that's going to be positive. So you see, it's the same thing we did in the last chapter. The only thing different is now I give you a new weapon. I give you your trig identities to help you find it. Feel free, this is the same problem. feel free that if you don't like that, to always go back to your triangles. You can say, all right, I don't like those identities. I'm in quadrant 3, so I'm going to draw myself a triangle in quadrant 3. Quadrant 3, I move over, I move down, there's my triangle. The cosine of the angle, which is right there, is -3/7. That means I went over 3. My hypotenuse was 7. I'll do Pythagorean's theorem. Oh, and look at that. A squared equals 40. A is 2 radical 10a, and I think you can see where this is going. And then I can just use my triangle to find my 5 trig functions, and they'll come out to be exactly the same as they did over here. Go out and enjoy the snow. Bye.